All right, y'all. We are out of school tomorrow due to the weather. So I am going to take care of your 1.11 notes today. Now, I did not have a hard copy here with me at the house. So I'm going to kind of go back and forth between your note copy and just some paper, which normally when I do binomial theorem, problems, I work vertically instead of horizontally, and you'll see that. So I wouldn't have room to write on your paper anyway, just because the way that I work the problem out. I will fill in a few things on here, and then the rest, like I said, I'll do the actual problems and working out on paper. All right. So a couple things about Pascal's triangle and the binomial theorem. So Pascal's triangle is ultimately how we are going to do the binomial theorem. So the first thing you're going to see here is if we're expanding this expression in general, anything a plus b to any exponent up here. Okay, that can be very tedious depending on how high your exponent is. Okay, so if we look at x plus 3 squared and x plus 3 cubed, if I just did x plus 3 squared, okay, you would do your distributive property. X times x is x squared. 3x plus 3x is going to be 6x, and 3 times 3 is 9. So that would give us x squared plus, oh goodness, hold on. Give me a second. Let's make this smaller. X squared plus 6x plus 9. Okay. Then if you look below that, so if we took this right here, and we know that's x squared, so we've got x plus 3 times x squared plus 6x plus 9. And then you would get the final answer for that to be x cubed plus 9x squared, if you worked all this out, plus 27x plus 27. Okay. And then if you wanted to do to the fourth, right, we could do another x plus 3 times our cubed answer, and then so forth. But again, the larger and larger this exponent gets, the more tedious that becomes working all of that out. So there is a shortcut. All right, so if we wanted to expand this x plus 3 to the seventh, this would be a very time-consuming process. Okay, so there is a wonderful tool to make this easier. Now, all this right here is, y'all, this whole thing right here, this is just explaining what Pascal's triangle is, but or why it works the way it works. So the binomial theorem does look intimidating and complicated, but it's really actually easy to use, and you can create it yourself. So I'm going to show you just the basic and then how we get to each row from there. Okay, so when expanding a binomial expression, the a begins with degree n and the b begins with a degree of 0. So a plus b to the n is what we're expanding. Okay, the a value begins with degree n, and our b value is going to begin with a degree of 0. Okay, and as you expand, your degree of a decreases by 1, while your degree of b increases by 1. Okay, until your b has the degree of n. Okay, all of those words make way more sense once we start working through the problem. All right, so the first thing I need you to know, okay, this right here is technically row 0. So this is your base triangle, 1, 1, 1. All right, so row 0 just means x to the 0. And we know anything to the 0 power is simply 1. So that's where that comes from. So this would be x to the first. Row 2 would be whatever it is squared. Row 3 would be cubed. Okay, so the important thing to remember here, once you start here, so row 1 is actually technically your second row of the triangle. All right, now, if you'll remember this, you can create your triangle. So literally all you do to fill in your triangle, this whole entire section over here, if you notice, is all ones. This whole entire section over here, if you notice, are all ones. All right, so what is 1 plus 1? 2. If I want to do the next row, I would do 1 plus 2. That gives me 3. 2 plus 1 gives me 3. If I want to do the next row, 3 plus 1 gives me 4. 3 plus 3 gives me 6. 3 plus 1 gives me 4. If I want to do the next row, and hopefully by now you're kind of catching on, 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 5. And you can keep going. So my point is, we could have come down here and we could create the next row. We know we got a 1 here and we got a 1 here. And then we're simply going to add our numbers. So that's going to be 8, 28, 56, 70, 56, 28, and 8. And then you can keep going. So if they asked you for row 10, you would have to create the row before it. A lot of times we don't necessarily ask for that high of one. I did create row 8 because we will ask for row 8 later on in your notes here. So we will need that row later on. But ultimately speaking, it's not a hard triangle to keep constructing as you go down. All right. So go ahead and flip that over. All right, the value of n over r corresponds to the rth element of the nth row of Pascal's triangle. The first number in each row is the 0 element of that row. Okay, so in the Pascal's triangle above, the 5th row is circled. In the 5th row, the first number, 10, has also been circled. The circled 10 is the second element of row 5. Okay. All right, this is a combination formula, and we do have a button for this in our calculator. Also, it's in Desmos as well. And if you're looking for the combination, you will not need to know this for AP Pre-Cal. We don't actually, now it is in stats, obviously, but we don't actually do this in Pre-Cal, so I'm not going to dive into that deeply. Okay, so here's where I'm at. I have 4 examples to do for you. Okay, and this is where I am going to go to my paper to show you how I write this out. Now, again, on your notes, okay, everything could go horizontally. That's the way the notes are set up for the amount of space I gave you. But for me, I am going to do this on a regular piece of paper because I am going to go vertically. All right, first thing I want to remind you, this is your A and this is your B. So in this situation, X is our A and 2 is our B, with our power being 5. Okay, so we will be using that 5th row, the row with a 5 as the second term. Okay, so whenever we go to example number 2, again, this would be our A, this would be our B. So it just depends on what they're asking you to expand as you go. All right, so let me move this, put this off to the side, grab some paper, and let's work out example number 1. All right, so example number 1 says they want to use Pascal's triangle to expand x plus 2 to the 5th. Okay, so again, I work vertically just because for me it's easier. Obviously, I'll write my answer as just a horizontal answer, but I do work vertically because I think it is easier. Okay, so if I go to the 5th row, my numbers were 1, 5, 10, 10, 5, 1. So that's the first thing I'm going to write. 1, 5, 10, 10, 5, 1. All right, the second thing I'm going to write is my A value. So in this situation, we said A is X. So I'm going to put X on each of my rows next. The third thing I have is I have my B value. My B value in this situation is 2. Okay. And then we talk about our exponents. So for our exponents, remember our A value starts with the exponent of the problem. So our A value is going to start with 5 and it's going to decrease by 1 each time. So it's going to start at 5 and it's going to go down 4, 3, 2, 1, none. Okay, there's a couple of ways you can do this. The explanation itself says the A value starts at 5 and works down. The B value starts at 0 and works up. So if I did that, then I would have a 0 here on 2, 1, 2, 3, 4, 5. Okay, so just a couple of things here. You can either go 5, 4, 3, 2, 1 all the way down, and then 5 all the way the other way. I do like to point out, make sure you're paying attention to the fact that your exponents should always add together to equal the power of the problem. So 5 plus 0, 3 plus 2, 1 plus 4, that should equal 5. All right, and then from here, we're just going to work out the problem. So you're literally going to simplify all of this out. All right, so 1 times x to the 5th times 2 to the 0. Okay, so that is the same thing as 1 times x to the 5th times 1. And I'm going to do that for each one of these lines. So 5 times x to the 4th times 2. 10 times x to the 3rd times 4. 10 times x squared times 8. 5 times x to the 1st times 16. And then 1 times x to the 0 is going to be another 1 times 32. So now I've worked out to simplify here, okay? And then I'm going to combine those into a single term. So that just gives me x to the 5th. 5 times 2 is 10, x to the 4th. 10 times 4 is 40, x to the 3rd. 10 times 8 is 80, x squared. 5 times 16 is 80, x to the 1st. And 1 times 32 is 32. Everything's positive, so I don't have to worry about my signs. They are all going to be pluses. So that's going to give me a final answer here of x to the 5th plus 10x to the 4th plus 40x cubed plus 80x squared plus 80x plus 32. So that is your expansion, your binomial expansion using Pascal's triangle for example number 1. Now, again, if you really wanted to, you could literally do x plus 2 5 times. Okay. All right. And now I'm going to show you, or if you look in the notes on your Canvas, you're going to see, I think it's written out horizontally there. It's the same thing. It's just this would be here. And then I just keep going this way with each one of these. Again, I just like to write it out vertically just because I think it's easier to see. It's completely up to you how you write that out. All right. So let's go to example number 2. All right. So here we are going to expand 2x minus 1 to the 4th. Okay, and again, we talked about our a here now is 2x, and our b is going to be negative 1. So just be mindful of that. All right, so this is example number 2. All right, so we're looking at row 4, which give me the coefficients of 1, 4, 6, 4, 1. All right, immediately I'm going to go to my x. So it's 2x for my a. So 2x, 2x, all the way down. And we know our exponents start at 4, 3, 2, 1, none. And then negative 1. 0, 1, 2, 3, 4. All right, so now let's simplify this out. All right, so we've got 1. Now, 2 to the 4th, or 2x to the 4th, sorry. You're going to have to do 2 to the 4th, which is going to be 16. And anything to 0 power is just 1. So then it's going to be 4 times 8x cubed times negative 1. And then 6 times 4x squared times positive 1. 4 times 2x times negative 1. And 1 times 1 times 1. All right, so if we work out that final answer here, all right, that's just going to give us 16x to the fourth. All right, 4 times 8 is 32 times negative 1 is going to give me negative 32x to the third. 6 times 4 is 24, x squared, negative 8x, and positive 1. So our final answer down here would be 16x to the fourth minus 32x cubed plus 24x squared minus 8x plus 1. So do notice that whenever we have a negative here, our signs are alternating. Okay. All right. Now, example number 3 and number 4 are asking for a specific part, which does make it a little bit easier. You don't have to do all the work for these two examples. You just have to do exactly what they're asking about. So for example number 3, okay, our problem is x plus 5 to the 6th. All right, and they want us to know what is the coefficient of the term containing x to the fourth. So they want to know what is the coefficient of the x to the fourth term. So I am going to write out my steps, okay? But then I'm not going to work all of it out. I'm only going to work out the one that involves x to the fourth. Okay, so we're talking about to the 6th. So we're looking at row 6. So our coefficients there are 1, 6, 15, 20, 15, 6, and 1. All right, our A is x. Our B is 5. Okay. And then my exponents again, we're going to start with 6, 5, 4, 3, 2, 1, none, and 0, 1, 2, 3, 4, 5, 6. But remember, we're only looking for the x to the fourth coefficient. Okay, so you're looking at this part right here. So all I'm going to work out is that. So that's going to be 15 times x to the fourth times 25. I'm going to work that out. That's going to give me 375 x to the fourth. So the problem itself asks for what is the coefficient of the term containing x to the fourth. So the answer is just 375. All right. And then the last one, example number 4. Okay, we are expanding x minus 3 to the 8th. And they want the x cubed term. Okay, well, x cubed, remember we start counting down. All right, so again, I already did that 8th coefficients in your notes because like I said, I knew we were going to need it. So 1, 8, 28, 56, 70, 56, 28, 8, and 1. All right, and we're talking about just x. So our next section is just x. Okay, so let's go ahead and figure those out. So that's going to be x to the 8, 7, 6, 5, 4, 3, 2, 1, none. So I only care about this one, the x to the third value. Okay, so then I'm going to go ahead and jump over here. It's going to be negative 3. And remember, because I know these two equal, I know that this is going to have an exponent of 5. So that's what I'm going to work out. So that's going to be 56 times x to the third times negative 3 to the 5th. Negative 3 to the 4th is 81. That's going to give me 243. And it is negative because we're a odd exponent. And then I would just need to multiply 56 times negative 243 to give me negative 13,608. X to the third. It only asked for the coefficient, so our answer is just the negative 13,608. So that would have been your notes for Monday. So that's what's expected of y'all while you're out, is to fill those in, go over those. I will most likely upload and I'll make an announcement about this. I'll probably upload a couple of questions in Delta Math just for practice on this. There's not a full homework worksheet, so there'll probably only be maybe 2 or 3 problems, probably 3 problems for you to work on just on practicing binomial expansion, and they won't be very long. Okay, you will need to turn in work for those though, not just a screenshot of your Delta Math. You'll have to actually submit your work into Canvas as well. All right. Y'all stay safe, stay warm, and I will see you back on Tuesday, and we will go into, I believe it's 19110. I think we skipped, unless, I don't remember. Whatever notes are next. All right. Y'all have a wonderful time, and I will see you back in school tomorrow.